So we have created our first level of the assignment of the assembly and the mechanism that we want, and in here we've fixed the housing and all the other bits of the assembly we've just locked together to make it quite simple. And then we've got two constraints or connections here, which we can see move that part and move that part. So rejig that, puts it back in its right place, and that's because we've got an angle constraint which has been added into this. So let's just show you what we've done there. By adding an angle constraint in and making it controlled, it still refers it to be revolute, which is what we need. And I've set the angle to -30 on this first one, between that plane and that plane. And then on the second one, we've also got an angle which is controlled, set the first angle 60 degrees from that plane of the main shaft and that plane the origin of the part. And I've allowed the lower and upper limit to rotate at least 10 full revolutions. So that's the first bit. But the next thing we've got to do is actually define the way in which the mechanism works. And although we could do some work within the assembly design, it really relies upon the mechanical systems design tool set, which changes our workbench, but also enables us to create a mechanism within this assembly. And if I just rename it something useful, so I'll call it the same, stage 2 Geneva mechanism, and OK that. And what it's done, it sets out this little symbol here and takes all of the connections and creates the joints within that mechanism, and anything that we've allowed to be driven, that is also given there. So if we double click on joints, we can see that the angle is driven off both of those things. And if I take out an angle and ask it to figure out what the degrees of freedom are, it might still work, but there's an error there. So by driving that angle as well, it enables us to get a fully simulated mechanism. That's the first thing, but of course it wouldn't necessarily work unless I told it some other conditions. And that is that I want a connection or a contact between that part and this part, and a contact between that part and that part. And those are placed on the assembly. In this particular tool set, we can see that we've got an extra definition for a connection called a contact. And it wants us to select the part. So in the first group, I select this piece, and in the second group I select that piece, and we can actually compute the mesh in there. It should, oh I know, is it? I can specify a mesh and compute it, and the system will compute a mesh to be able to do that calculation. And there isn't really much need to actually change much here, but if I OK that bit, I then also need, let's just update that, also need another one that goes between this piece and this piece. Compute the mesh and OK that. And what that's done, if I update that, if we go back and have a look at our joints, we've now got two additional joints placed in the assembly, and I need to accept and put those into the calculation, and it's still okay to compute. So how do we actually work with that now? If we go into the commands there, we can see a player, and we can, let's just move these about so you can see this sort of moves, but it looks like there might be a bit of a problem with it. Reset that to beginning, and we'll just see what we can do with the next bit. So the next thing we have to do is actually work in another app, the Mechanical Systems Experience, which again changes the workbench and puts this whole assembly inside I'm not going to make a scenario, I'm going to OK that and give this a name, and we'll call this stage 2 kinematic simulation. And then you can see that the assembly that we worked with is actually in here, and we can build some scenarios based upon our model set. So what we're going to do first of all is to create a dynamic scenario, and I can OK that, but without some things to move it's a bit irrelevant. So what we're going to do is create a velocity law, and the support it needs is in fact one of those commands. You can see it won't select any of that, but I'm going to pick the first command, which is driving this wheel. 10 turns a minute it's defaulting to, and if I then double click on this, it's actually put that law, the excitations, what makes it move, is in here, but of course I need to add it in to the scenario, update it and preview that scenario and see what happens. Now it's not actually making a move on that.